Okay, to prevent this from happening, the first thing to do is to remove this normally open stop push button here and replace it with a normally closed switch. And now, because we have changed this switch, we remove this normally closed contact in the program and replace it with a normally open contact. Now we can go ahead and save the program, then download it to the PLC. When operating in online mode, because IO1 is a normally closed switch, we first make its bit true manually in the simulator. Now, if we press the start switch once, the motor will be turned on continually. And then, when we press the stop switch, the signal path will be cut off, just like before, and the motor will be shut down. So now, you can see that after implementing these changes, the system is working properly, just like the previous program. So with these new settings, let's disconnect the stop switch wire once again and test the program to see what happens. With this wire disconnected, we press the start switch, and we see that unlike the last time, the motor will not turn on at all, a bug indicator. Now, let's reconnect the wire and press the start switch to turn the motor on. Now we disconnect the wire while the motor is running. As you can see, the motor shuts down immediately, another bug indicator. So when we use a normally closed stop switch instead of a normally open one, as soon as the stop switch wire is disconnected, we are notified. This helps to make the system safer. So, from now on, as an automation engineer, if someone asks you, what's the real reason for using a normally closed switch for stop buttons, unlike most engineers, you don't have to fob them off. In the next lesson, we'll learn why we need to use a feedback contact when the motor is turned on.